All right, so for homework, you had to analyze our rational function here, and we would pretty much find all the parts that we would need to sketch it. So I'm going to sketch it as we're doing it. I didn't ask you to do that, so it's fine if you didn't. Obviously, you have graphing utilities at your disposal, so sketching it doesn't, you don't really need to do it because you have Desmos, you have graphing calculators. All right, so here we had the function x squared plus 2x plus 1 over 2x squared minus 1. So the first thing I just asked you is, does it have a simplified form? So I didn't ask you to simplify it, but you need to simplify it to find out if it's got a simplified form. So what we want to do is we want to try to factor. Right, so our numerator, x squared plus 2x plus 1, we want to try to break that up. All right, well, our end term here is 1. There's only the only factors of 1 are 1 and 1. And everything's positive, so I can put pluses there, and that works out, right? Because I have x plus x, that gets me the 2x. In the denominator, we have x squared minus 1. All right, so that's a perfect square. Hopefully you recognize those, and you automatically break it up to x plus 1 times x minus 1. So the next thing you're going to do is you're going to look for common factors in the numerator and denominator, and what do you know? They both share an x plus 1. Be careful, you can only cross out 1 in the numerator. You have to keep that second one because there's no other x plus 1 there. So this does have a simplified form, so your answer for number 1 should be yes. Okay, again, I didn't ask you for the simplified form, but you need this to move on. Okay, so remember, we are taking this into consideration when we answer our questions. Now, I can't forget that this was here. Okay, anytime we remove anything, it's a removable discontinuity. So that tells us that we have a hole at x equals -1. All right, so we're going to hold off on that. That's just something that, we tell ourselves as we're graphing it. So the simplified version, it doesn't really help me sketch the graph. All right, I'll get that going down here. All right, so I can't really add anything yet with the information that we have here. Okay, it does have a simplified form, and it's got a hole at x equals -1. So the second thing I asked you is, what is the y-intercept? So we're going to plug in f of 0, x equals 0. Now you could do it in this one, but that's a little more work than just plugging it into here. When we plug x equals 0 here, we get +1 over -1. So our y-intercept is -1. So right away, going down to our sketch, I can plot that point, -1 there. Then we ask for x-intercept. So our x-intercept, we just look at the numerator, and we set the numerator equal to 0. Okay, for this, make sure you're using the simplified version. Even though it doesn't matter here since we get the same answer either way. X plus 1 equals 0, I get my x-intercept to -1. But be careful. I know I have a hole at -1. So instead of plotting a closed circle at -1, that is going to be an open circle because that's where my hole is, all right, at x equals -1. the next question I asked you the horizontal asymptote. All right, so remember the horizontal asymptote, we have to look at our rule, right? We have our three situations. Here, my exponents are the same. Here, my exponents are also the same. It doesn't matter, okay? So since the exponents are the same, we're looking at the coefficients of our highest power. So horizontal, I don't know if I mentioned this, but I want to reiterate it if I did. Horizontal asymptotes are always going to be y equals a number, okay? Because a horizontal line is y equals. So looking at the coefficients, it's 1 over 1. So our horizontal asymptote is just 1. All right, so be careful. You're not looking at the numbers back here. You're looking at the leading coefficients. So my horizontal asymptote, okay, is going to be y equals positive 1. All right, so I draw a dotted line that our graph won't cross there. Now I look at the vertical asymptote. Again, I have to focus on this simplified version. The vertical asymptote, we look at the denominator. So we get a vertical asymptote at x equals positive 1. Okay. Again, I don't know if I mentioned this, but vertical asymptotes will always be x equals a number, since that's what gets us a vertical line. All right. So as far as what I asked you question-wise, oh, and then the last question I asked is, if the function can be simplified, are there any holes? Well, that's what we found here, a hole at x equals negative 1. All right, so this part you didn't have to do, but if you did it, this is how you would do it. So for the graph, we have a pretty good picture of our left side here. Okay, so it would come close here. All right, I would pass through this. I still have that hole there. And then I come down and I go this way. So normally, right, most of the time, it's diagonal, all right, the second part of the graph. So it should be over on this side. But let's pick a point over here just to make sure. So on the right side of my asymptote, I can pick x equals 2. So when I plug in 2, I get 3. So 2, 3. All right, I was a little off with my curve, but I was in the right part of the quadrant, right? That upper right corner there. All right, so there is our sketched graph. And then just for consistency, I want to check it out on the calculator. So I'm going to type in both equations. Well, first I'm going to type in x plus 1 divided by x minus 1. All right, and that looks pretty close to what we had. And then again, if you hover over here, it doesn't show the removable discontinuity because this is the simplified version, right? I don't know if I can do it here. No, okay. Right. But if I typed in the entire version that we had, so that would be x squared plus 2x plus 1 divided by x squared minus 1. Okay. Well, the graphs are the same, right? They lie on top of each other. But looking at the full equation, it doesn't. Oh, it does get. That's interesting. Okay. So it doesn't show that there's a hole here. That is interesting. Okay, but usually we've seen it before. It'll say undefined. So I guess what it does is it automatically simplifies it. Oh, no. Okay, there we go. Yeah, -1 is undefined. There we have the whole. Maybe it was reading the second graph, the first graph. No, that's really strange. Okay, we just saw it was undefined. I don't know why it's doing that. All right, any questions about the homework?
No, but can we try practice? Like, can we do another example?
Another one? Sure thing. All right, let's get out. All right, let me look up a problem for us. Oh, I don't know. How much time we got? Okay, so I'm gonna see how fast. Oops, I can get through this one because this is a special case. All right, let's take a look at the function 4x over x squared plus 4. All right, so going through this, we'll kind of go through the same steps because those are usually the same. Can we simplify this? So in the top, I have a 4x. All right, so I have two factors. I have a 4 and an x. In the denominator, if I had x squared minus 4, I could break that up, but I can't break up x squared plus 4. Okay, so this doesn't have a simplified version. Okay, so no simplification. All right, so let's find our intercepts. Okay, and I'll start a really small, tiny graph up here to kind of give us a feel. I might have to add more ticks there. That's real sloppy, but you get it. So our y-intercept, excuse me, we plug in 0. Well, in the numerator, I get 0. So it doesn't matter what the denominator is, I get 0. So my y-intercept is 0, 0. So now when I'm doing the x-intercept, I should find that I should have at least one intercept at 0. All right, so let's try it out.
I have a question.
What's up?
What do you mean no simplification? We can simplify the bottom part.
If it was x squared minus 4, then that becomes x plus 2, x minus 2. But because it's x plus 4,
Yeah.
we can't do that. Okay, but good, yeah, good question. Or good point. All right, x-intercept, we set the equation equal to 0. Okay, and we solve. So again, the denominator doesn't matter. I multiply both sides by x squared plus 4, and I still get 0. Well, I get my x-intercept. I only have 1 at x equals 0. So we have the same point that we found for the y-intercept. So not much there. Our horizontal asymptote. Looking at this, the denominator, I'm sorry, the denominator exponent is greater than the numerator exponent. So that tells us we don't have to do any math. We have a horizontal asymptote at y equals 0. So this is, okay, so yeah, this is why I wanted to show you. Even though my asymptote is y equals 0, I have a point that lies on the asymptote. Okay, this is a special case. Now the vertical asymptote. So we said there's no way to factor x squared plus 4, so we'll do this algebraically. We subtract 4 from both sides, x squared equals negative 4. And before we move any further, this is kind of an issue. There's no squared number I'm going to get negative 4 with, right? If I solve this, or if I tried to solve this, I'll get x plus or minus the square root of negative 4. So this is a rare instance where we don't have a vertical asymptote. Okay? There's no holes because there's nothing that we can remove from the bottom. Right? So you can go through these steps and just be careful. You may end up with like no helping information, right? I can't really sketch anything from here. What I have to do is I just have to pick points and plot them. Okay, so let's look at the graph real quick. Let me get rid of these. So I have 4x divided by x squared plus 4. And this, I'm going to have to zoom out. Come on. This is a really interesting graph. It's not even really a hyperbola. Okay, we kind of get this wave function. And the asymptote is kind of applied retroactively. So it passes through the asymptote, but then once it goes above that, it starts to come back down, and then it acts like an asymptote again. Okay, it'll get closer and closer. And then on the left side, it does the same thing, but negative. Right? It passes through the asymptote, it comes down a little bit, and then it bounces back. All right, so I just wanted to show you that, you may not get straight up answers. All right, let's do one more with actual, whatchamacallits, asymptotes and things. All right. All right, let's take a look at x squared plus 3x over x squared plus x minus 6. In the numerator, although it is not a classic trinomial quadratic where you have something like this, okay, we can factor the top. They both share an x. So I get x times x plus 3 in my numerator. In the denominator, that does break up. To x plus 3 times x minus 2. So it does have a simplified version of x over x minus 2. All right, so y-intercept. Plugging in 0, again, we get 0. All right, so it's the point 0, 0. Our x-intercept, looking at the top, x equals 0. Right? We set the top equal to 0, and there's nothing else to do. X equals 0. So again, right now, we don't have a whole lot of help. All we have is that point there. So now for the horizontal asymptote, we have similar powers. Okay, 1 over x to the first, x to the first, x squared, x squared. So looking at the leading coefficients, 1 over 1, I have a horizontal asymptote at y equals 1. All right, so I'm just going to put that there. Vertical asymptote, we look at the denominator, x minus 2 equals 0, x equals 2. So that was 1, 1, 2, so maybe over here we have our vertical asymptote. And we have this point here, okay? Now we just got to be careful. We removed x plus 3 as a factor. So I have a hole at x equals negative 3. So wherever x equals negative 3, maybe over here, and I would have a hole. It would come down through that. And then we would have the second part of the graph up there. All right, so I think we've identified all the parts. We've sketched the graph. And with the last few minutes, let's take a look at our actual graph to make sure everything lines up. So I have x over x plus 2. I'm sorry, x minus 2. Okay, and there we have the graph. It looks, mine's a little sloppier, but it looks pretty much the same. And then again, if we plug in, this should work, hopefully. Okay, here's our second function, which again matches right on top of that first function, right? The simplified version. And let's see if it actually. No, that's really strange. Oh no, okay. Yep, there we go. It is unidentified at negative 3 because we have the removable discontinuity there. All right, that's where we got our hole. Any questions about that? All right, so tomorrow we are going to move on to finding slant asymptotes. And then depending on how long that'll take, that'll be the last thing we'll talk about for rational exponents, rational equations. And we'll move on to exponential and logarithms. Fun stuff. All right, guys. If you don't have any other questions, that's all I got for you today. Have a great day, and I will see you tomorrow.